Okay, well, we're back, and while we were gone, I meshed the rest of the structure, at least the shell elements, right? And so you can see that here. But, these are not connected, so we need to add the welds, and we will also need to add the fasteners, okay? So we're going to model the screws. So let's first start by doing the welds. And so, as I mentioned briefly in class, there's several ways that we can do the welds, but a simple way is to sort of approximate the connection with RBE 2 elements, or you can even span some more with RBE3s, but like I said, I think the one RBE2 is kind of not a bad idea because, if you model all the weld material, it's probably stiffer than it really is. So this is sort of a compromise between those two. Again, probably it would be interesting to actually try two different types of, different types of modeling the weld and then see how they stack up experimentally. But let's just focus on actually making the elements here. So we're going to do RBE2 elements to kind of connect up this C channel to this, I think that's the upper bracket, right? Yeah, to this upper bracket. And I'll just do one, and then you can do the other ones, okay? So first thing I'm going to do is I'm going to make a new component layer just to hold the weld elements. So let's make a new component. I'll call it welds, okay? Let's give it a color so I can see it. And I don't really need to put a property on here because these are going to be RBE2 elements and they don't really have properties anyway. So you can just leave it like this. Now to generate the RBE2 elements, we're going to go into this 1D panel, okay? And this is always the weird thing. I think, yeah, okay, that works. So by default, if you go into rigids, it will use an RBE2 element, okay? So that's fine. And all you need to do is just connect the two nodes. So we can go from channel to angle or angle to channel. It doesn't matter. It's a good idea to kind of keep them consistent. And then the mathematics of dependent and independent node won't really become an issue. But let's say we want to do a weld bead, so we maybe want to go from this node to this node, and maybe this node to this node, right? And so now we're adding those rigid connections. Okay. If you wanted to, add a second layer, you could do that. I think that's probably not necessary. Like I said, I think that will probably make it too rigid. The RBE2 elements tend to be a little bit more rigid than you want. If you wanted to do something like this, I would actually be tempted maybe to span it with RBE3 elements, but let's not get into that. Okay, so let's delete that last element. All right, whoops, delete elements. Why did it delete? Okay, delete that element. There it goes. Now it's gone. Okay, so that created the RBE3 elements. Like I said, we can go through and add them to all the other welds. Okay, and that would be it. All right, so next let's add a fastener. And again, we'll do it at all four of these, but let's just do one, and you can do it for the other ones. So this will be a 1/4-20 screw. And remember, what we're going to do is we're going to use a CBAR element to model the actual effective length of the screw, and then connect that through with an RBE3 element, okay? So let's first define the property for the screw. So these are going to be P-bar property, or actually it's easier to use a P-bar-L property because that makes it a little bit easier defining all the parameters. So let's do that, property. And it's not going to be a P-shell, it's going to be a P-bar-L. Where is that? P-bar-L. And again, if you don't know what all these cards are, they're all in the linear static user's guide, okay? The material is going to be steel, right? It's a steel fastener. And the type it is a rod. It's just a solid cylinder. And the one parameter we have to put in is the radius. So there's the one value we put in the radius. So a 1/4 inch screw would have a radius of 1/8 of an inch. Okay. All right. And give it a color if you want. So it's ready to define that element. We actually need to generate the nodes, right? There's no node like at the center of the circle and then offset from a little bit. So I need to actually do those. That's not too hard to do. Let me show you how to generate those nodes and then we'll make the element, okay? So to generate nodes, we can go into geometry and there's a simple way to do this. So if we click nodes, it gives us several options. But this one here with like a circle arc and a node at the centers is the easiest one. So this will generate a center node, either with the geometry of a circle or by picking 3 nodes on the circle. So we'll select this to be nodes, and then we'll pick 3 points on the circle and do create, and there's our node. All right. Now I need another one that's just a little bit down from there. The shank of the screw is basically about 1/8 of an inch. They're very short screws that go into the test fixture. So let's take this node and we will copy it. So to do that, we'll go under Tools, and we're going to translate that node. All right, and we're going to translate it in the Z direction by 1/8 of an inch. All right, but we need to duplicate it. Okay, so I'm going to say make a copy of it and not just move it. We click node again and then select duplicate, excuse me. And what that'll do is that'll make a copy as opposed to just moving that one node. So there it is. The translation's actually in the negative Z direction, so we'll translate minus. And there you go. You can see now we have 2 nodes. All right. All right. So now we can create the 1/4 20 screws. So let's make a collector for whatever it's worth, and I call it 1/4 20 screws. Okay, and again we give it a color, I guess. Now I think in this one we can give it a property. We'll give it the, oh, you know, I should have named this property. So we'll select that, go back to this property, let's rename it. Let's call it. So we'll also have the 1032 screws, right? 1/4 20. Okay. And there we go. All right, so now to generate the CBAR element, it's pretty easy. We go to 1D and bars. And again, we want to change the element type to be a CBAR element. Now, I don't know if it'll automatically take it from the property level, but if you want to, we can specify the property here. Again, remember you need to do an orientation vector. So the orientation vector has to be a vector that's not in the same plane, or not collinear with the axis of the element. It indicates which is the I1 and the I2 direction. Now, for a circular cross section, it doesn't really matter, so we can pick anything. So I'll just pick the Y direction, but we do need to prescribe it. All right, and we're going to go from this node to this node, and there you go. There's the CBAR element. All right. Now, next thing we need to do is take that CBAR element and connect it to the support with some RBE3 elements. So again, that's also under 1D, and there's actually a window, a menu of RBE3. So we'll pick that, and we're going to create. Okay, so the dependent node will be explicitly defined. So we will pick that, and then also the independent nodes. So the dependent node is going to be it's going to be the one that's on the fastener, the center one. And the dependent nodes are the ones that span to the plate, okay? And there you go. All right. Okay, so there's that one. And again, you would just repeat that process for the other places you want to put the fasteners, okay? Get rid of these temporary nodes, okay? clear all. Okay. So there you go. Actually, you know, you can also kind of, if you want to cheat a little bit, you can actually copy these things. So we can do Tool, Translate, and we can just copy these elements. So we pick the CBAR and the RBE3 element. Now we have to remember to make a copy. So we're going to say duplicate, and keep them on the original component. And the way we're going to move that is just by picking 2 points. And the magnitude will be the difference of those 2 points. So I think it's good enough we can actually just pick from like this node to this node and say translate plus. And you can see there is our copy. I can do it again if I pick this and then do duplicate again, original component. And now let's pick the nodes. We'll go from here to here. I think that'll work. There it goes. And then let's copy it again. Original component. Start node is here, and then the end node is there. Translate plus. Okay, so there they are. Now, what happened though, even though we moved them, and it has nodes very close, they're actually not connected yet. So we need to connect these. And there's actually 2 nodes that are very close to each other. We want to merge those and make them one node. So for example, what I'm saying is, there's actually a different node that's the terminus of this RBE3 element as opposed to the node that's on the shell. So we need to equivalence those, is the terminology that Hypermesh uses. So that is also going to be under Tools and Edges, and then you can pick like elements or components. So I'm just going to pick a big window of these elements. And what this is going to do is it's going to say any nodes that were within a specified distance, I'm going to merge them and make them one node. So basically what's here is any node that's within 10,000th of an inch, which I think I can even go a little bit less than that. Let's do 5,000th of an inch. It'll merge together. Now sometimes if that's too big, it'll actually collapse elements. So you want to see what you have before you actually do the merger. So this preview is good. And that looks good. And see, it's just doing the ones that I think it should. So we'll equivalence and that's fine, and now they're actually connected, okay? All right. All right, so we've put the fasteners in, and we've done a weld, and actually, I guess the one other weird thing we could do is we could add a concentrated mass. So, for example, we need to put the electronics package out here. So, where is it? Where's that block? There's a block. Actually, it's out here. All right. So we know the weight of this is 0.37 pounds, and basically at the center here. So we can put a concentrated mass right in the middle of this block. All right. So we'll need a node there. So let's create a node. So we'll use geometry nodes, and we'll actually end up using this function, which allows you to interpolate between 2 different nodes. But before that, I need nodes on the edge. So this one will allow me to put nodes on an edge. So I can do 2. I think that'll work. So we'll click this edge, and we'll create 2 nodes on that edge. And we can do this and create 2 nodes on that edge. And then basically, I will put a node between these 2 points, between this point. Okay, wait, node list. Between this node and this node. All right, and that puts a node right about in the middle. All right, so now let's put the concentrated mass element here, which is a con M2. Again, so that's going to be under 1D masses, and there it is, a con M2. So we can put in the mass here, which is going to be the 0.37 divided by 386. Again, I don't know what that is. Figure that out. So that is 0.000958. Whoops. Wait, return. Okay, so that's actually the mass of the electronics package in slinches. and it is going to be right there. Let's pick that node and create. Okay, and there is the concentrated mass. Now we'll need to connect that. So I would probably create the fastener here, and then connect to that with an RBE2 element, okay? So let's imagine, well, let's just do this real quick. Let's put a node sort of at the center here where the fastener would end, so we can actually do that with, again, the same way we did it for the shell elements, but we have lines here, so we'll change this from nodes to lines. So now if I pick that line, create a node right in the center, create a node in the center. Somebody really wants to call me. Okay, I'll call back in a second. Let me just finish this and I'll be done, okay? So the RBE2 element is again a rigid, and we will pick the independent node. Is this one here, and then here to here. Okay? All right, let me pause there. And then next time we'll set up and do the modal, okay?